We've got one more lesson with triangle proofs. We're basically going to be adding on to what we've done in the past two lessons. The first lessons, we talked about the ways that we could tell that triangles are congruent without knowing every single side and angle. We have these 5 triangle congruence postulates. And we're going to add on to that today with this right here, CPCTC. That stands for corresponding parts of congruent triangles are congruent. So what we're going to be doing with these is proving 2 triangles are congruent, just like we did in the previous lesson. And then once we know that the 2 triangles are congruent, then we could say that certain parts of them are congruent. In this first example, it gives us that AE and EC are congruent, also BE and ED are congruent, and we're trying to prove that AB and DC are congruent. What we're going to need to do first is prove that 2 triangles are congruent, and then we're going to say that AB and DC are parts of those congruent triangles, so they must be congruent. So first, let's figure out if we have enough information right now to say that these 2 triangles are congruent. Right now we have 2 sides, and we can't use one of these yet. We need to find another side or angle. So looking through this list, do you see something else that we could use to find another side or angle? This has vertical angles. These 2 angles are vertical angles, so they must be congruent to each other. So I'm going to put that those 2 angles are congruent to each other because they are vertical angles. And that's going to give me another angle. So now I have 2 sides and an angle. Then, do we have enough information to say that these 2 triangles are congruent? Yes, we have 2 sides and an angle. The angle is in between those 2 sides, so we can use side, angle, side. So I'm going to put that these 2 triangles are congruent. Remember, the order of the vertices matters when you are naming the triangles congruent. So if I say ABE for this one on top, A corresponds with C, so I have to call the one on the bottom C, and then B corresponds with D, and E corresponds with itself. That's side, angle, side. So it doesn't matter which order you name the first triangle with, but the second one has to correspond. Next, now that we know that these 2 triangles are congruent, after we have used one of these 5 theorems, we can say that parts of those 2 triangles that correspond to each other would have to be congruent. A lot of times, CPCTC is going to be the very last step. Now that I know these 2 triangles are congruent, AB and DC would have to be congruent segments. I could basically just copy what it says up here. AB and DC would have to be congruent to each other because they are parts of congruent triangles. 2 triangles that we just proved are congruent. Since we just proved these 2 triangles are congruent, then these 2 parts of those are congruent. So really, a lot of these, we're just adding on this step after proving the 2 triangles are congruent of saying corresponding parts of them are congruent. Let's do another similar type of question. It gives us that AD is congruent to BC. It also gives us 2 angles that are congruent. And we're trying to prove that AE is congruent to BE. What I want to do first, before I could prove that those are congruent, is to prove that we have 2 congruent triangles. There are a couple of different ways to do these, so there's multiple ways to get to the same answer. And I'm not sure yet, if I'm looking at this, do I want to prove that these 2 kind of littler triangles are congruent? Or do I want to prove this whole big triangle and this whole big triangle are congruent? Let's figure out if the sides that we're trying to find are going to be part of this little triangle and this little triangle, or the big ones. And since we're trying to prove that AE and BE are congruent, those are going to be parts of these two smaller triangles. I suggest that we start off by proving that these two smaller triangles are congruent. That would be ADE and BCE. In these two triangles right now, we have a side and we have an angle. We need to figure out if there are any other angles or sides, and to do that, as we know, we can go through this list, and you should notice that just like the last question, these two triangles have vertical angles. So I'm going to say that those two angles are congruent to each other because they are vertical angles. Angle DEA and angle CEB are congruent vertical angles. So now within these two smaller triangles, I've got a side and two angles. Would this work for angle, angle, side, or angle, side, angle? It works for angle, angle, side. So now I'm going to state that these two triangles are congruent. I could say ADE, and if I label the first one as ADE, how will I have to label the second one? BCE. And like I said, that is angle, angle, side. Now we know that these two triangles are congruent. So we haven't used this line. We would use that line if we were looking at the bigger triangles. We haven't used the line AB. All right, next, now that I know that these two triangles are congruent and it's asking me to find AE to prove that AE and BE are congruent, those are parts of the two triangles that we just found out are congruent. So we can basically copy down this statement and say that AE and BE are congruent because, surprise, surprise, this is going to be the last answer for most of them that you do on this practice. Corresponding parts of congruent triangles are congruent. You can only use this CPCTC right after you use one of these 5 theorems. Let's do another example. We have that AB is congruent to BC. We've got D is the midpoint of AC. And then this isn't like yesterday where we're just proving that two triangles are congruent. We're going to need to take it a step farther, prove BD bisects ABC. So overall, I'm trying to prove that BD, this line right here, bisects this angle. So I'm trying to prove that those two angles are congruent. The method we're going to use for all of these questions is to first prove that two triangles are congruent. The two triangles that are congruent that we need to prove are congruent are going to be those two triangles ABD and CBD. Right now, I've got one side in each of those. Let's see if we can find any other sides or angles. If we use the fact that D is the midpoint of AC, what does that tell us? That tells us that AD and CD are going to be congruent segments because midpoint means it splits it into two equal parts. So AD and CD are congruent because of the definition of midpoint. We've now got two sides. Do we know any other angles or any other sides? We have BD is equal to itself because it is reflexive. BD equals itself because of that reflexive property. Now, do we have enough information to say these two triangles are congruent? Yes, we can say these two triangles are congruent. Triangle ABD and triangle CDB are congruent because of side, side, side. We have all sides and no angles. Next, after we use one of these, we're frequently going to use CPCTC. I can't go ahead and say that CD bisects ABC yet. I first need to go in and say that these two angles are congruent. So those two angles that we're going to eventually prove were bisected are going to be angle ABD and CBD. And how do I know that those two angles are congruent? Because CPCTC, that's what we frequently use after one of the 5 triangle congruence theorems. So now that I know that these two angles are congruent, then we can kind of go backwards about bisect. So I can copy this, what it wants us to prove. I could basically copy that down, and it's not bisecting a segment. It's a segment bisecting an angle. So I would say BD bisects ABC, and it's because, this only gives us one option, but if it's 2 congruent angles, it must bisect. So again, this pattern you're going to see for a lot of them, we prove that the 2 triangles are congruent, and then we prove that 2 parts of those triangles are congruent. Another example, this one's going to be a little bit tougher. We have 2 segments that are congruent, AD and AE, and this one's actually going to give us that 2 triangles are congruent. Triangles CFE and BFD, those are these smaller triangles right here and right here. So we know that those 2 triangles are congruent. Because those 2 triangles are congruent, that's going to give us a lot of information. Because if these 2 triangles are congruent, then I know that all of the corresponding parts and all of the corresponding angles are going to be congruent to each other. So that gives us a lot of information. What I'm going to do is separate the 2 triangles that we are trying to prove are congruent. This one's a little different. It's not ending with a CPCTC like most of them do. We're going to be using a CPCTC earlier in the proof because it gives us already that 2 triangles are congruent. So I sort of separated out these triangles. We're going to look at triangle BAE and triangle CAD. Those are what we are ultimately trying to prove are congruent. So I'm going to label these. And AD and AE we already know are congruent, so I'm going to go ahead and mark those 2. Then I'm going to see if there's any parts from these 2 triangles that I can kind of steal to prove that these 2 triangles are congruent. I'm kind of stealing them because I know everything is congruent to everything in these 2 triangles. So I want to see that if there are any parts within these 2 smaller triangles that are shared with the 2 bigger triangles, basically, so that I can kind of steal them to show that I've got some congruent sides or angles. Right now, I see that in these 2 little triangles here, that angle B and angle C are parts of those little triangles, but also parts of the big triangles that we are trying to prove are congruent. So I'm going to use that angle B and C are congruent to give me a pair of angles in the triangles that I'm trying to find ultimately are congruent. So that would be angle B and angle C. I don't have to label this with 3 points because those are the only angles there. And since they gave us 2 triangles are congruent here, I can go ahead and use CPCTC. But you can't use CPCTC unless you've used one of these, unless you've said that 2 triangles are congruent in the previous step. So that gives me 2 more angles. I've got a side and I've got 2 angles, but we're going to need more than that for all of our triangle congruence properties. So we need to look for anything else, any other way to find any other congruent sides or angles. If we go through our checklist and we looked at the first thing on the checklist is reflexive property. Since these 2 triangles are overlapping, we probably are going to have something that equals itself. Can you figure out what would overlap, what would equal itself in these 2 triangles? Both of these triangles have angle A. angle A is where they overlap, so they both have angle A. So we would need to say that angle A is equal to itself. So I'm going to choose two angles. Angle A would equal itself because of the reflexive property. We use that one a lot if you haven't noticed. And then I have enough information to say that BAE and CAD are congruent using what postulate? Angle, angle, side. Let's look at one more example together. We are given that there are two sets of congruent sides in this diagram, and we're trying to prove that another set of sides are congruent. And the way we're going to do that is by trying to prove that there are two congruent triangles and then stating that two parts of those congruent triangles are congruent. So this doesn't tell us which two triangles that we need to prove are congruent, but it wants us to prove that BE and BD are the congruent sides. Those are the two sides that we're trying to prove are congruent. And working our way backwards, if we're trying to say that these are part of two congruent triangles, then the triangles that we make need to have those two sides in them. So I usually kind of work backwards and figure out which two triangles I'm going to need to prove are congruent so that I could say that those two sides are congruent. So since BE and BD are the two sides that I'm trying to prove are congruent, then I would recommend that we state that triangle ABE, this triangle, is congruent to CBD. I would recommend that we try to find a way to prove that those two triangles are congruent, because then in the last step we could say that BE and BD are part of those congruent triangles. Right now on these two triangles, ABE and CBD, I've got two sides. And we know that two sides is not enough to prove that the two triangles are congruent. We're going to go through and look for any sides or angles using this checklist. Are there any sides or angles that overlap in both of these triangles? No, there's not. Are there any parallel sides? No, it doesn't tell me anything is parallel. Are there two congruent sides or two congruent angles in one triangle? In other words, is this an isosceles triangle? Well, this one's kind of hard to see, but if we look at the big triangle, so the entire big triangle, triangle ABC, this entire big triangle right here, that is an isosceles triangle. If I come over here and draw it separately without the lines on the inside, and I mark that this side and this side are congruent, hopefully it's easy for you to see that that right there is an isosceles triangle. So yes, we do have two congruent sides in one triangle. And in a triangle, whenever there's a triangle, angles opposite of congruent sides are congruent. Or going the other way, if there's two congruent angles in one triangle, the sides opposite from them are congruent. So this means if we are looking, let's say we're looking just at this yellow triangle here, which is triangle ABC, since we have two congruent sides, what two angles are across from the two congruent sides? The two angles that are across from the two congruent sides, they're also called the base angles. Across from this side we have angle A, and across from this side we have angle C. So because this big yellow triangle is isosceles, that is going to give me two congruent angles. Angle A and angle C are congruent angles because they are base angles of an isosceles triangle. Let's type that in. Angle A is congruent to angle C. There's only one angle involved at the point A, so I don't have to label that with 3 points. Same thing with C. The reason for that is that this is an isosceles triangle, and in a triangle, angles opposite of congruent sides are congruent. Angles opposite from congruent sides are congruent, and that's just in one big triangle. Anytime you have one big triangle, you could state within that triangle there are two congruent angles. Now let's see if that's enough information to prove that these two triangles are congruent. Triangle ABE and triangle CBE. If we look just at these two yellow triangles and look at the sides and the angles that we know so far, that is enough information to state that they are congruent. And which reason would we use? This is side, angle, side, because the angles that are congruent are formed by the two sides that are congruent. I will type in that ABE is congruent to which triangle? CBD, remember the order does matter since A corresponds with C. If A comes first, C would have to come next. And the reason for that, like we said, would be side, angle, side. Now that I know that these two triangles are congruent, the last step in a lot of these is that CPCTC. So since I know that these two triangles are congruent, then I know that corresponding parts of them are congruent, and BE and BD would have to be congruent because they're part of congruent triangles, they're corresponding parts. So I would say that those are congruent by CPCTC.